Hi everyone, this is Dr. Nuck, and we are going to go over section 7.8. The title is Phase Shift Sinusoidal Curve Fitting. So basically in this section, we're asked to graph functions of the form y equals a sine or cosine of omega x minus phi plus b. So I will show you how the textbook does it first, so that way you won't be all confused, and I will show you how I would do it next. But anyway, so let's just follow what the textbook does. So step number 1, find the amplitude, period, and phase shift. Okay, so all the formula is given right there. So the amplitude is again absolute value of a, period is 2 pi over omega. Phase shift can be determined by phi over omega. Now, if phi is negative, you're going to have to shift the graph to the left. If phi is positive, shift it to the right. Now, step 2, find the starting point of one cycle, which is given by phi over omega, and find the end point of one cycle, which is phi over omega plus 2 pi over omega. And they want you to divide the interval into that. And you might want to, as before, you might want to divide that in an equal length. And step 3, use the points of the subinterval to find the 5 key points on the graph. And step 4, plot 5 key points, connect the dots to make a sinusoidal graph to get one cycle of the graph. Extend the graph in both directions to complete. Step 5, if b does not equal to 0, apply the vertical shift. Okay, let's do an example. Find the amplitude, period, phase shift, and graph label key points of y equals 3 cosine of 2x plus pi. So let me just first jot down, so this is of the form y equals a cosine of omega x and minus phi and plus b. Okay, so that way we can determine what a's and omega and phi's and b's are. All right, so with that said, let me just write this in red. Our a is 3, amplitude is 3. Our omega is 2. Phi is negative pi. And b is 0. Okay, so keep that in mind. Okay. So let's first go with step 1. Again, I'm doing this according to the textbook's method. Alright, so step 1, find the amplitude, period, and the phase shift. Okay, so let's go with the amplitude. I'm just going to denote it as amp, which is the absolute value of a, so amplitude is 3. Alright, now let's go with the period. Oops, period is denoted by t. The formula is 2 pi over omega. So in this case, you're going to have 2 pi. What's omega is 2. So you're going to get pi. All right, next one is the phase shift, which is given by phi over omega, which is negative pi over 2. Okay, so that's our step 1. Now let's go with step 2. Alright, step 2 is we're going to have to get the starting point. Okay, so I'll write every step out. Starting point. Now, formula for that is phi over omega, which is negative pi over 2. That's our starting point of the interval. And our endpoint is phi over omega plus 2 pi over omega. So this is negative pi over 2 and plus 2 pi over 2. So this is pi over 2. Let me know if I made a mistake or something. Alright, now let's go. Oh, so we're not done with step 2. So we need to divide. So next step, what we need to do is we need to divide negative pi over 2 to pi over 2 into 4 subintervals of equal length. Alright, so basically this is what's going on. So we're going to start from the interval. Starting is negative pi over 2 and end is pi over 2. And then we're going to chop this into 4 equal pieces. Okay, so in order to do that, let me see the length. So the length is what? 2 pi over omega divided by 4. So which is pi divided by 4, which is pi over 4. So the increment of each interval, subinterval, is going to be pi over 4. So starting from negative pi over 2, this point is negative pi over 2 plus pi over 4, which is, let me just erase this portion, which is what, negative pi over 4? Oh, just write it like this, negative pi over 4. And negative pi over 4 plus another pi over 4 will be this point. So negative pi over 4 plus pi over 4. So this is 0. And next one should be pi over 4. And the next one is pi over 2. So the subintervals are negative pi over 2 to negative pi over 4. Negative pi over 4 to 0. 0 to pi over 4, and then pi over 4 to pi over 2. Lots of writing. All right, we got this. Now let's go with step number 3. All right, so what do they want us to do? So use the endpoints of the subintervals to find the 5 key points. Okie dokie. All right, so let me just write everything out. Use the endpoint of the subintervals to find 5 key points. All right, so we got this. So first, let's go with the first interval. First interval at the endpoint will be what? X equals negative pi over 4. Actually, if they want 5 key points, what you need to do is you need to compute the value at negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. So those are the 5 key points that they're looking for, I believe. All right, so we can do this. So let's go with at x equals negative pi over 2. So our y is going to become what? 3 cosine of 2 times negative pi over 2 and then plus pi. Okay, so then this is going to be what? 3 cosine of, that would be negative pi plus pi, which is 3 cosine of 0. Now cosine of 0 is 1, so our answer is 3. 3 times 1. Okay, now let's go with when x is negative pi over 4. Okay, our y is 3 cosine of 2 times negative pi over 4 and then plus pi, which is going to be 3 cosine of, what is that, negative pi over 2 plus pi, which is 3 cosine of pi over 2. Cosine of pi over 2 is 0, so 3 times 0, so which is 0. So much writing. Alright, so now let's go with x equals to 0. So our y equals 3 cosine of 2 times 0 plus pi. So this is just 3 times cosine of pi. Alright, cosine of pi is negative 1. So it's going to be -3. Alright, so what's the next one? X equals pi over 4? Okay, so in this case, what we're going to get is y equals 3 cosine of 2 times pi over 4 plus pi, which is 3 cosine of, what is that? Pi over 2 plus pi. Pi over 2 plus pi is what? 3 pi over 2? Which is cosine of 3 pi over 2 is 0. So we get 0 back. Okay, how many more do we have? 1, 2, 3, 4, 5. One more. Alright, so then next one is at the very end. X equals to pi over 2. So then here you're going to have y equals 3 cosine of, oh man, 2 times, what is that, pi over 2 plus pi. So this is 3 cosine of 2 pi. So this is 3 times 1, so we're gonna get 3. Alright, take a little breather. Okay, so now let's go with step 4. So step 4, plot the 5 key points. Okay, so let me just write down. So when x is negative pi over 2, our y value was 3. And when x is negative pi over 4, it was 0. And then 0 comma negative 3. And pi over 4 comma 0. And then pi over 2 comma 3. Alright, and graph one cycle. Okay, so does it look equal lengths to you? Alright, so anyway, so this is negative pi over 2, negative pi over 4, and that's 0, pi over 4, and then pi over 2. Alright, so you're gonna go up 3, down negative 3. Okay, so when x equals negative pi half, it's 3. And up negative pi over 4, back to 0, and then goes to negative 3, pi over 4, and then pi over 2 back at 3. So our graph, it's going to look something, oh my gosh, like that. Actually, that's not a bad graph. Kind of did it. Right. Okay, so this one is our y equals 3 cosine of, what was our function again? 2x plus pi. Now, since b is 0 in this case, there is no vertical shift. So let me write that. So step 5 was what they want you to check, vertical shift. But since b is 0, no vertical shift. Alright, so there you have it. So that is how the textbook does it, but let me show you how I would do this. So let's just go with the same problem. Graph y equals 3 cosine of 2x plus pi. And of course, we're going to plot all the key points and whatnot. And graph one cycle. Sorry, let me just write that. Graph that in one cycle. Okay, so first, let's go with the amplitude. Just like when we did the graphing for sine and cosine, we're going to follow the same procedure. So the amplitude is absolute value of a, which is absolute of 3, which is 3. And let's just go with the period. Okay, so what is the period of cosine of x? It's 2 pi. So what we need to do is 0 less than or equal to less than or equal to 2 pi. Okay, now what goes in there is the argument of the cosine. So here you're gonna have to insert 2x plus pi, and all you gotta do is just solve for pi. I mean, not solve for pi, sorry, solve for x. Okay, divided by 2, so it looks like our interval is going to become negative pi over 2 less than or equal to x less than or equal to pi over 2. So when x equals 0, that spot is going to be replaced with negative pi over 2, and instead of a 2 pi, that place is going to be replaced with pi over 2. That's all. Okay, so let me just draw the mother graph. Is y equals cosine of x. Remember, I'm only looking for just one cycle. Okay, so cosine graph starts high, 0, low, 0, high. That will be just one cycle. Okay, so let me label all the key points. So this is pi over 2, pi, 3 pi over 2. That's a 3 on the top, sorry, and then 2 pi. Okay, now let me just draw another graph directly below. And we're going to shift our the intervals a little bit. So let me do the same thing as what we did before. Now, instead of starting from 0, that 0 point on the mother graph is going to become negative pi over 2. So this point right here is going to become negative pi over 2. And then instead of a 2 pi, your 2 pi is going to get replaced with just a pi over 2. All right, now the dead center will be the 0. So let me just draw that out. So that will be our new grid for the graph that we're looking for. Now, if I chop this up into 4 subintervals will be equal length, so since you have 0 to pi over 2, 0 to pi over 2 divided by 2 will give us what? Pi over 4. So this point is going to be pi over 4. And so that means this is negative pi over 4. Okay? Now, notice that the amplitude is now going to become 3. So I'm just going to do this in one shot if that's okay. So instead of a 1, 1 becomes 3, and negative 1 becomes negative 3. All right, and then all you have to do is draw out the same graph as you see above, directly below. So it's going to start from 3, and then 0, negative 3, 0, and then 3. That's not too bad. So this is our graph of y equals 3 cosine of 2x plus pi. Now to label the key points, I think that's pretty straightforward now. So key points are, I'll just jot it down in red. So the first point is what? Negative pi over 2 comma 3. Second one over here would be negative pi over 4 comma 0. And this guy is what? 0 comma negative 3, pi over 4 comma 0, and then this is pi over 2 comma 3. So I mean, I'm pretty much doing the same thing as what the textbook does, but I'm trying to do everything a little bit shorter, and that's all. Feel free to use this method on the exam or when you do your homework. Alright, let's go with example 2. We're going to do the same thing with the function y equals 4 sine of pi x plus 2 minus 5. I think this is as difficult as it can get. So if we can do this problem, I believe that rest of the homework problem should go nice and smooth. So let's do this. First, I can follow the steps 1 through 5 as your textbook does it, but let me just show you how I would do it. And in my notes, I will make sure to write down how the textbook does it from step 1 through step 5. Okay, so first, what I would start out with always, amplitude. And as you can see, amplitude is absolute value of A, so it's going to be 4. And then let's determine the interval, which we could go with the period. So what is the period of sine of x? It's 2 pi. So we're going to play the same game. Now what goes in there is the argument of the sine. So you're going to insert pi x plus 2. And we're going to solve for x. It's going to look ugly, I'm just warning you, as you will see in a minute. And divided by pi. You see how ugly that is going to be? Okay, so here our interval is going to be negative 2 over pi, less than or equal to x, less than or equal to 2 pi minus 2 over pi is same thing as 2 pi over pi minus 2 over pi. So that should give us 2 minus 2 over pi. Okay, so instead of starting from 0, that 0 point is going to become negative 2 over pi. And instead of a 2 pi, you're going to have to replace the 2 pi with 2 minus 2 over pi. Okay, now if we want to determine the period, so this will be the graph of a one cycle. So one cycle better be between these intervals. So to determine the period, all you have to do is, I'll just write it down. So period, all you have to do is take the endpoint minus the beginning point. Endpoint minus the beginning point. Alright, so in that case, what do we get? 2 minus 2 over pi, that's our endpoint. And then minus the beginning point is minus 2 over pi. So minus minus going to become plus. So here our period is going to be 2. Okay. All right. And then, also let me just write it out. So period is going to be just 2. All right. Now the phase shift is always going to be the starting point of your graph. So in this case, phase shift is going to be starting of the graph is what? Negative 2 over pi. So that's it. Oh, let me just insert. Phase shift is always the beginning. Oops, why is that in red? Sorry. Of the interval, so that will be negative 2 over pi. Alright, so what I'm going to do is start out with the mother graph. Mother graph should be y equals sine of x. And all I'm looking for is just one cycle. Alright, so the sine graph goes what? 0, high, 0, low, 0. Okay, so this is the mother graph. Okay, so now since amplitude is 4, do you see what's going to happen? At the end, this is going to become 4, this is going to become negative 4. Okay, so on the next step, let me just try to shift the interval. Let me see what I can do here. So let me just draw this line. Alright, so when x is 0, starting point is going to, instead of a 0, it's going to be negative 2 over pi. So this point right here is going to be negative 2 over pi. And the end point here, instead of a 2 pi, we're going to have this crazy number 2 minus 2 over pi. So now you're going to have to divide this into 4 equal subintervals. But look at it. Period was 2, wasn't it? So meaning from here to here was the period was 2. So if I want to find the 4 subintervals of equal length, all you have to do is what? 2 dividing by 4, so which will be 1/2. So all the grid is going to be shifted 1/2 units. So let me just jot down these values. So this is going to be really ugly. So ready? This point is going to be negative 2 over pi plus 1/2. And this point is going to be negative 2 over pi plus 1/2 plus 1/2. So that will be 1. And this point right here is going to be negative 2 over pi plus 1 plus 1/2, which will be what? Plus 3/2. And that's what's going to happen. All right, so all you have to do is this. Draw the graph, the mother graph of sine of x above. And would it be all right if I already changed the amplitude to 4 and a negative 4? I hope that is okay. Let me just do it like this. Oh my gosh, now that point is missing. So let me just erase this point and let me just write it out nicely. So the starting point was what? Negative 2 over pi. Alright, so instead of 1 and negative 1, I'm just going to go ahead and go 4 and a negative 4, if that's okay. Alright, and then what's going to happen is it's going to go 0, high, 0, and then low, 0. Just one cycle. So this is the graph of y equals 4 sine of pi x plus 2. Crap, we're not done yet. We got the vertical shift going on. So what we need to do is we want to graph y equals 4 sine pi x plus 2 minus 5. So what we need to do is take this graph and then shift it downward 5 units. So all you have to do is subtract the y value by 5. So in order to do that, let me first jot down the key point. So key point here is what? Let me just write it over here. Negative 2 over pi, comma 0. And this point right here is, oh, this is so ugly. All right, negative 2 over pi plus 1/2 is the x value, and then y value is 4. And then this point right here is negative 2 over pi plus 1, comma 0. Yikes. All right, now this point right here, I'm running out of room. All right, I'll do the official graph on the next page then. So this point right here is going to be negative 2 over pi plus 3/2. And then the y value is negative 4. And this point right here is another ugliness, which is 2 minus 2 over pi, comma 0. Okay, so all you have to do now is to change the y value. So the first point, let me just, oh my goodness, this point right here, your x value stays the same, but y value, you're gonna have to go 0 minus 5. So the new point, let me just write down the new key points on the bottom. So the new key points, all right, it's going to become negative 2 over pi, and then 0 minus 5, which will be minus 5. I hope you can read this one. All right, now the second one, which is what? This ugliness right here. x value stays the same as negative 2 over pi plus a half. And then the y value is just 4 minus 5, which is just going to be negative 1. Let me just go like this so you don't get confused with what's what. All right, and then the third one, a third key point, it's going to be negative 2 over pi plus 1. X value does not change, and you got 0, so you got a 0 minus 5, minus 5. And then next key point is x value again stays the same. And then you got minus 4 minus 5, so it's going to have minus 9. And the last one is going to be 2 minus 2 over pi, and then 0 minus 5, which will be minus 5. So these are going to be our new key points. Let me put that. So what we're going to do now on the next page is to plot these points and then graph our final result. Final result meaning the final graph. Okay, so you can scroll back to the previous page to get the new key points, but let's just jot it out. So the new key points, the first one's going to be what? Negative 2 over pi comma negative 5. So negative, so it's right here. So this point is going to be negative 2 over pi comma negative 5. And the second key point became what? Right here. This was negative 2 over pi plus a half comma negative 1. And then the next one was back to here. So this was negative 2 over pi plus 1 comma negative 5. And then it went down to negative 9, I believe. So this was negative 2 over pi plus 3 over 2 comma negative 9. And then back to this point, which was 2 minus 2 over pi comma negative 5. So let's connect those dots. That's the funnest part. But I'm not very good at it. Oh my gosh. Okay, you get the idea. All right, so this is my graph. This is my final graph of y equals, what was our function? I even forgot. 4, what was it? Sine of pi x, was it plus 2 minus 5? I believe that was it. So there you have it. Now again, I will do this how the textbook does it on my notes, but this is just the way I do it. I'm pretty much doing exactly the same thing, but I think this might go a little bit quicker. Alright, next topic in this section is building sinusoidal models from data. Okay, so I already wrote down everything out. The goal is, given some data points, you want to come up with sinusoidal function of best fit to model the data. Alright, so don't worry, we're going to do examples in a minute, but on the picture, the black dots are the data points. Okay, and let's look at y1, y2, and y3. Do you see that y3 might be the best fit curve for the given data points? So our job is to come up with such functions. All right, now let's go through the steps for fitting a sine function y equals a sine of omega x minus phi plus b to data. Step 1, find the amplitude. So how do you find the amplitude of the given data? Would be the largest value minus the smallest data value, whole thing dividing by 2. Step 2, find the vertical shift, which is denoted by b, which will be the largest data value plus the smallest data value dividing by 2. And what we want to do is we're going to have to find that omega. Now, omega can be found by 2 pi dividing by t, where t is 2 pi over omega, which is the period. Step 4, find the horizontal shift by using the period. Divide that into 4 subintervals of equal length, and find the x-coordinates of the max of the sine function, and find the x coordinates for the minimum of the sine function, and use these info to find the value of the phase shift, which is phi over omega. I know. You probably, this probably is not making any sense to you right now. It's like a bunch of gibberish, but don't worry. We're going to do some concrete examples in a minute. Okay, example. The following data represented the average monthly temperature for Baltimore, Maryland. Okay, so I hope you can see that. So we're given January, February, all the way up to December, and then we're also given the average monthly temperature in Fahrenheit. So but I've already jotted down the scatter diagram as part A. So all I did was the x-axis denotes the month, and the y-axis denotes the temperature. So when it's January, the temperature is 32.9. That's why I have plotted right here. And February, it's 35.8. So maybe right here, I figured that might be 35.8-ish, and so forth. I just plotted those points. Okay, so the part B is find the sinusoidal function of the form y equals a sine of omega x minus phi plus b that models the data. All right, so step number 1, we got to do the amplitude. So the amplitude, we're looking for value of a, so it's the largest value of the data minus the smallest value of the data, whole thing dividing by 2. Okay, so that's gonna be, let me see, hold on one second. So that's, what is the biggest data value? Is it 77? And then minus the smallest is 32.9. Whole thing dividing by 2. So 22.05. Looks like that's gonna be our amplitude A. So this is our A. So now, so therefore, what do we got so far? So therefore we have y equals 22.05 sine of x so far, where x is the month. So this is what we have so far now. So the graph below, I already drew the picture out. I already worked this ahead of time. So what I just did was I just drew the graph of y equals 22.05 sine of x in that, what color is that? Yellow color, yellowish color. And so that will be this function here. But that's not quite touching the graph, so we still have to do something about it. Now we might want to shift this above, so let's find the vertical shift B. So B is given by the biggest value plus the smallest value dividing by 2. So here what we're going to get is, instead of a minus, we're going to have a plus here. So you got 77 plus 32.9 dividing by 2, which is 54.95. And that is our value for B. So let me box that. So this is B. So what do we have? So therefore, we now have, let me just write it in red, y equals 22.05 sine of x, and then plus 54.95. That's what we have so far. Now, I already drew the picture on the bottom, so what I did was taking the graph above in the orangish curve that I drew. Now the key points, all I did was shifted all the key points by 54.95 units above. So the negative 22.05 mark, if I add 54.95 to it, you get 32.9. So the very low point is going to be shifted here. Okay, and then the 0 mark is going to become what? 54.95. So that's why I have it marked here. And then let me see. And the highest part will be 22.5 if I add it. So the highest value is going to be right here. So keep that in mind. And what I did was I just drew the same sine graph directly above in purple. Okay, next, step 3. Find omega. So note that t is the period. And that just tells you what the time it takes for the data to repeat. So I'll write everything out. Time it takes for the data to repeat. So how often is it going to repeat? Since the data repeats every year, January through December, so that means what? Period better be 12. Okay, so don't worry, here we go. Since data repeats every year, our t must be 12. So the one cycle better end in the interval from 0 to 12. Okay, so now let's find omega. So omega was what? 2 pi over t. So this is 2 pi over 12, so which is just pi over 6. So this is going to be our omega. So therefore, we now have, let me just write it in red, y equals 22.05 sine of pi over 6x, and then plus 54.95. Okay. Now, when the omega equals to pi over 6, that means that that indicates the horizontal stretch factor. Now, when you stretch the previous graph horizontally by a factor of pi over 6, the maximum and minimum values is going to occur at the endpoints of the 4 subintervals of equal length. So that is a fact. So don't worry, I will write down everything for you in a minute. So let me just write it as omega is a horizontal stretch factor. And let me just write this in blue. I'm going to say when you stretch the previous graph horizontally by a factor of pi over 6, the maximum minimum values occur at the endpoints of the 4 subintervals of equal length. That is a fact. So since we're dealing with 1 through 12, right? So our interval is going to start from 0 and then 1, 2, and so forth. Or maybe 1 to 12. So if I divide this, well, let's start from 0. And then here is 1. All right, so if I divide this by, what, 4? Each length is going to be 3. So, oh my goodness. I'm sorry, this is getting so messy here. Okay, so let me try this again. Okay, so this is 0, that's 12, so you're going to have 3, and then what, 6, 9, and a 12. So the subintervals are going to be 0, 3, 3, 6, 6, 9, and then 9, 12. Okay, so what I did was I tried to draw the previous graph, which is y equals 22.05 sine x plus 54.95. That's in purple. Now, what's going to happen now is this. At each of the endpoint, the max and min is going to occur. So at 3, let me see if I can do this. At 3, the maximum value is 77, isn't it? So 77, comma 3 will be here. Okay, the next one is 6. So next one is going to be 54.95 because we're trying to draw the sine function. 54.95, it's maybe right here. So this is 6 comma 54.95. And the next one is, it's going to occur at 9, and the minimum point is what, 32.9? Oh gosh, 32.9 is right here maybe. Alright, so this is 9 comma 32.9. And then at 12, it's going to go back up to 54.95. Alright, and of course starting point is here, which is 0 comma 54.95 because we're drawing the sine function here. So let me just try to connect these dots. Oh my gosh, where's the other green one go? Oh, here it is. Oh my gosh. Alright, pretend that I'm trying to draw a sine graph over here. Alright, so this, the green one will be the graph of y equals 22.05 sine of pi over 6x and then plus 54.95. Whew, almost done. Okay, now step 4. Still continues. Alright, now let's find the x-coordinate for the maximum of sine function and the maximum of the data. Okay, so find the x-coordinate for the max of sine function, which is what, x equals to 3, and then maximum of the data is what, x equals to 7. Keep that in mind. Let me just box that because we need this information. Alright, so therefore our phase shift is going to be maximum of the data minus the maximum of sine function, which will be 7 minus 3, so our phase shift is going to be 4. So what you need to do, this means that you need to shift the graph that I drew in green, the previous graph, by 4 units to the left. Okay, so let me just spell everything out. This implies that we need to shift y equals 22.05 sine of pi over 6x plus 54.95 by 4 units to the left. So, which implies that replace x with x minus 4. That's all you got to do. Alright, so it looks like, finally, so therefore the final answer it looks like the best fit sine function for the data is, what do we get? Y equals 22.05 sine of pi over 6. Now x is going to become x minus 4, and then plus 54.95. Okay, so that implies that, let's simplify, 22.05 sine of pi over 6x, and then what? So distribute the pi over 6 to 4, 2 pi over 3, and then plus 54.95. Oh my gosh, that was work and a half. And here you have it. And if I graph this nicely, let's see what's going to happen. Okay, so I just paused the video and then just wrote down the datas again. What a pain in the butt. Okay, so now let's make this chart so that we can see things in a little bit of a better way. What color can I use? Let's use blue. Okay, so if I make an XY chart, okay, I'm gonna go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, I'm going to compute the corresponding y value of our official function. Alright, so if you plug those values in, you should get 35.85. When x is 1, like 32.9, 35.9, and then 40, I got, what is that, 54? Sorry about that, wait, number 3 is 43, sorry, 0.9, and April 54.95, May is 66, June is 74, July is 77, August 74, and September is 66, 10 is October 54.95, December 43.9, and 35.6. Feel free to use your calculator on type of problems like this. So, oh my gosh, I have to plot this. Alright, so 35 something will be like right here. And next one is what? And x is 132.9. 32.9. Oh my gosh, I don't. Okay, February 2 is what? 35.9? 35.9. And 343.9. Does this look 43.9 to you? Alright, and then 4 is 54.95. 54.95. Okay, 5 is what, 66? Okay, and then at 6 is 74. Sorry. All right, and then 7 is 77. All right, and then 8, 74. And back to 66. And when 54.95. Completely drawn off the scale probably. All right, and then when x is 11, 43.9, 43.9. And 12, what do we get? 35.6. Okay, I think this is good enough. All right, there you go. So this is the graph of our official function. That was like the longest problem ever, but we got it. Good job, everyone. And for the next example, what I did was, as an example 4, I did the number of hours of sunlight on the summer solstice of 2014 problem. I believe that I wrote out everything in detail, so I think you should be able to follow it. So I'm not going to video on this section. This is also going to be on your notes as well. So please go over this. So I have that, and we pretty much did the same. I pretty much did the same thing as the example 3 that we just went over. And all the details are listed here. So if you're interested, please go over this example on your own. And of course, if you have any questions, please let me know. And there's the rest of it. All right, good job everyone, and I will talk to you soon.